Good morning. Welcome to Making Stuff with Chris DeHut. For today's video, we're going to take a look at a real-time clock. I personally haven't utilized them a lot in microcontrollers for whatever reason, but today there's more and more need for them because we're incorporating them more and more into IoT type projects or other things that need timing. So I went on Amazon and I picked up this unit here. It was rather expensive. It's $19.59, and I just find that outrageously expensive. But I thought it's probably a very high quality unit, and so I went ahead and bought it. Now, I'm sure there's cheaper units out there, but I am avoiding this practice of buying things only based on the cheapest price, simply because often they're garbage and don't work. In this case, I've kind of got mixed emotions on it, but we'll get into that in a moment. It does come in a nice package, as they show there, and I'll show you the device here. This is it on the back side. It's got pass-through headers, and then all the guts are inside this area. It comes with the battery. There's the chip for the real-time clock. It's well labeled and well marked so that you can get your Pico put onto it in the correct order. They tell you where the USB connector is. All around, getting that part together was pretty straightforward. When we get into a little more of the details, we're going to find out you got to solder in a jumper. And that gets to be a bit of a challenge. It's certainly doable, and I'll show you that here in a few minutes. Now, real-time clocks, their purpose is to provide a real-time clock, not necessarily something that we set once and we're working off of an inaccurate computer crystal or microcontroller crystal to keep a sort of time. This is supposed to be real-time. Now, as I recall, it would have been around November 11th when I set this up initially here in the lab. And it was rock solid accurate to my computer clock this morning on December 18th. So it sure didn't lose a second in that time. And the chip that they're using is from, I'll call up the data sheet, from Maxim, and they call it an extremely accurate I2C real-time clock. And so that might be adding to the cost of it. So the guts of this thing are, for the most part, high-end component. As far as looking at the data sheet to start with, not a real lot in here that we really need to concern ourselves with. It does go into a lot of detail about the chip. If you want to incorporate one into your own project, I'm sure you can garner some information out of here, but nonetheless, I'll include that in the source code package that I usually do with all these videos. I did go to their website. Let me call that up here because it's a Waveshare brand, and yes, they are out of China, but they've done a pretty good job of documenting all their products, and this is no exception. But you have to find the information in English, and that's generally on their wiki site. I'll try to remember to include a link to this either in the program or a link on the description down below. But they do give you a little bit of information up here that's somewhat important if you're into a lot of detail stuff. Most of this I literally just scrolled past because they're talking about installing a lot of other stuff, a lot of work that you generally don't need to worry about. But what we did want to do, they reference us to this others thing. With this real-time clock, it also has an alarm function, and that's where things kind of soured for me. Now, in truth, I could have screwed something up. I'm a human, and I'm interpreting this data as anyone else would. But I went to the schematic, and you have to solder or connect where resistor number 5 would be. And it's a 0R, or just a straight-up jumper. 0R meaning zero resistance jumper, or no connection for no function. And that's to connect GP3 on the Pico to the interrupt function of the DS3231. And if we scroll down to this part of the picture, that is this jumper right here, or this resistor location, and that is right here on the back side of the real-time clock. And you can almost see the jumper I put in there, but I'll show you also how on the microscope that I've got. I took video of it and a photo of it there to show you in big scale. And I've checked it out very thoroughly. Yes, the connections are good. It is kind of a pain. The solder that they used is probably paste, and it's probably very high silver content. So soldering into it with traditional solder can be a little bit of a challenge. Nonetheless, at this point, I just want to say I was very disappointed. I could not get the real-time clock alarm function to work properly or to work at all. It isn't something that I personally would have incorporated into any projects that I could think of. So it's not a huge issue for me, but I wanted you to be aware of my experience with this project or with this device so far. Now, also on their website, they're going to reference documents that we can download, schematic, data sheet, which we've just looked at, and then demo codes. And that'll be demonstration codes in C and in MicroPython. Of course, we're reflecting on that Python version of it. Once I downloaded it and expanded it onto my computer, again, it shows C source code in demo program, and then Python. And it's just one file, and it's actually a class structure file. So it makes it really nice and easy to work with. And they've named it nicely, the same as the chip ID number. Moving into the program, I don't really want to go into a lot of detail on their class. We'll treat that as a magic box. They wrote all the code. For the most part, it's functional. I couldn't really figure out the alarm function, and the code looks straightforward and correct. I couldn't find any mistakes in there, but everything else is functioning and working correctly. But they're going to, in their class module here, which is where we're going to be putting our demo code, they're going to import some libraries, establish ports and pin numbers for the I2C interface. They've got a note that if it don't work, try this, which is a little concerning. Then this is the class when they wrote it, a few other details there, setting up some registers that are important for communicating with the real-time clock. And then from here, I did modify just a couple things. I turned off some print statements that were printing, especially in the read time function, or method in this case. And I turned off the print there, and I literally copied it, but then I added a function or a capability for a return of that same data. So whatever it was printing here, we're returning that from our call to the read time function. And that'll make a little more sense here in a moment, but I added that line here and noted that in their program. This was a set time function or method, and like I say, it didn't work. It's very disappointing. I was hoping to show you more detail, but it is what it is. This function here I'll explain in a moment. That was added by me to add functionality that suits how I would utilize a real-time clock. And then we get down into their main code or the main portion of the program, from the original file that they provided. Now, in truth, almost all of this that isn't commented was added by me, and we'll explain that in a moment. But the first thing we have to do is get the real-time clock set to the current time. That's extremely important. If you don't do that, accurate to the second, so to speak, it will always be off. So what you would do, we're going to uncomment this line right here. Normally you would have that commented like so. But we're going to uncomment it and put in the time at about a little bit later than what it is right now. Currently we're at 12:15, so I'm going to change that to 12. I got a little work here. I'm trying to decide how long it'll take. I'm going to put it at 12:16, and then probably 03. I'm going to guess it'll take 3 seconds from the time I hit run for it to execute that code. So I might be off by a few seconds there. But when we run this, that will actually set the time on the real-time clock. Now, if we go back to the desktop here, we need to make sure we've got the battery installed and installed properly. And then we would put our Pico on top, push it into place. Now I'm going to connect it, hit stop, and I'm going to be setting it for 12:16. So the clock on my computer, as soon as I see that hit 12:16, I am going to execute this program. So bear with me if there's some awkward silence. Okay, click the run button. It's set the time. We'll see that scroll by here, and then it's going to execute the program code down below here. While it's doing that, I'll go about explaining a few other things. First thing I would do is recomment that, because we only need to set the clock once. As long as the battery doesn't come out of it or go dead, it will maintain time. Here we're going to call their read time function, which is right here. That gathers the data for all the calendar information or time information that you would want, and it will return it. Now, the first time I'm just reading it and not doing anything with the data, and I'll print it. We saw that scroll by here a little bit ago. And then I'm going to take that current time in the format that they provide, and I'm going to call a function called getIntTime, and that's get integer time. The data that is returned in this function is string data, and you really can't do much with string data if you're processing time. So what I did, I created a very simple little function that would get the year, month, day, hour, minute, and second from that very descriptive information and give us integer values from which we can work. So I literally just say year, we're going to want the integer, make that equal to the integer of time that was returned from the original function, and that would be from position 0 to up to position 4, the first 4 digits. And then I gather the rest of the time and date values out of that, and then we return it back into our routine here, and then I printed out each element of the time function that comes from the real-time clock, and then we can work with that data however we want. Here, after I get all the data, then I'm going to print it. I'm also going to capture a current minute. And again, I'm going to be processing that, so I want that as the integer. And that's noted here when I say print I_year. These are all the integer versions of that time statement. So I go while the current integer minute is equal to the current minute, or while the integer minute is equal to the current minute, which I gathered right here, we'll run this loop. And then from that, I'm going to then read time from our original library here, read time. I will then convert that reading into integers again, and I'm going to print it out, and that's what you saw scrolling here. It'll print 60 minus the current second. It's a countdown timer that we're emulating here. And then we'll sleep for 1 second. No sense going any faster than that in our loop. We're only counting in seconds. And then when it gets done, we'll print the end of the countdown. But as you can see, doing that with string would be an extra step where we would have to get the data, extract it out of that long string, and then from there convert it to an integer, and then do the data processing. So I'll go ahead and run this again, and if it's depending on where we hit on the clock, okay, rats. Okay, now here we can see, let me copy that because it's going to scroll off screen, and I'll just paste it in down here just so we can discuss it. CT was returned, calling that other function, the original, read time. It returns the date and time in this format. It's very fancy, it looks great, and it's very functional for a lot of things such as a simple clock or calendar. But if we want to do processing of that data, that's where my function comes in handy. And of course, you're going to utilize that in any way, shape, or form that you would like. But this is how I want to work with real-time clocks on a microcontroller. I want to be able to work on dates, times, where I can lay out intervals of things to happen or wait for a specific date, time, down to the second to perform an action. And doing that with integers is substantially easier than strings. Now, I do know that there are Python functions available to work with dates and times and scheduling and so forth, but I'm trying to work at this and demonstrate this at the most fundamental level. From the real-time clock, we can get real-time date and time out of it, and we can process that locally. So this pretty well wraps up my discussion on a real-time clock. It would have been fun if we could have set the alarm and done some playing with that. In truth, I don't think I would ever utilize the function, but nonetheless, it's there and it would have been nice to work with. If one of you folks, you go through and try to get that to work and you get it to work, share that with us down in the comments below. There's, like I say, there's good probability I goofed up something. Perhaps I didn't, and this function actually doesn't work as stated. I did look over the website a little bit, and I didn't see any clear indication of them advertising that capability. And honestly, I didn't even know about it until I got into reading their data sheet, or reading the data sheet as well as their documentation on their wiki. I'm going to show you one more thing that I was somewhat disappointed in. I'm going to take this device apart again, and I need a little poker here to point out something. On the battery holder, there are two little tabs, or should have been two little tabs here and here, and those help retain the battery from falling out. Now, I've had my battery in and out probably a dozen times, maybe even more, while I was preparing the program and doing some experimenting and so forth in preparation for this video. Well, those two little tabs are gone, and I think I can show you what they look like. If we go back to, okay, whoops, let me get that big again. Now, of course, when I put my mouse over it, but what I want you to do is see right there where my mouse halo is. I'll move it out of the way, and you can see exactly what I'm talking about, that little hook there that'll hold the battery in. I may have broke them off, or they may not have been there, but the problem is the batteries are already fallen out on me a few times. So that was another disappointing factor of this for a $19.59 real-time clock, where it left me disappointed. Nonetheless, it's an easy fix. A dab of hot glue on there, and that'll keep the battery in until I need to take it out and change it when it's dead. I didn't really intend this video to be kind of a downer or a critique of this device. I just wanted to share the fact that there are these devices called real-time clocks that we can incorporate in our projects that give us the ability to do things based on actual time. And that's very important in certain projects, especially IoT projects. But hopefully through taking you through their program and then modifying it, I've made it a little clearer for you to utilize it in your projects and to get you to think in terms of, yeah, their information's great, but if we convert that to integer and work from that, it might be more useful to us as makers. So that's going to wrap it up for this project. I probably will try to do another real-time clock video in the future, just because I want to kind of further along to find out if there's less expensive versions of real-time clocks that have equivalent functionality, where we're not feeling like, wow, I got to put a $20 clock on a $4 microcontroller. One of those deals. Nonetheless, thanks for watching, and I look forward to seeing you in the next video.